Assalamualaikum warahmatullahi wabarakatuh. My name is Hesfa Yolda Murad.
I'm Atifa, so today we will explain about our research about hydroxyapatite from Kupang shells as halal alternative bone graft. Kupang is a sea organism that commonly found on the coast of East Java, especially Surabaya and Sidoarjo. Reporting from detik.com, every day one truck of Kupang is dumped into the sea because it can be disposed at the final disposal site. Reporting from Gunawarman 2010, Indonesia is one of the countries with a high amount of fracture sufferers. There are as many as 300 to 400 cases of bone surgery per month in Dr. Sutomo Hospital, Surabaya.
According to Turkey's Ministry of Health and the Scientific and Thermal Research Council of Turkey, 95% bone graft in the world are produced from pig bones. Based on the data from Badan Pusat Statistik (BPS) in 2010, Indonesia population reached 237.6 million people, with Muslim population as much as 87%, or about 207 million people. This means that the majority of Indonesian people are Muslim. Muslims need to use halal products, so this will be a concern for them. Not only that, most of the bone grafts that are distributed in Indonesia are imported from abroad. According to Triono, in 2019, imported bone graft costs very high, which is about 1.7 million rupiah per 5 cc. Based on that information, it is important for us to produce alternative bone graft from halal and affordable ingredients, which is Kupang Arcuatula Senhousia. This will also help to reduce the potential of environmental pollution due to Kupang waste.
So, what is the objective of the research? To synthesize hydroxyapatite from Kupang as an alternative ingredient for halal and affordable bone graft. We want to know does hydroxyapatite from Kupang could be used as an alternative ingredient for halal and affordable bone graft. This research was conducted at SMP Islam Al-Azhar 13 Surabaya and Research Center Chemistry at LIPI. Start from July 2019 until now. This research was carried out in 3 stages, which are material preparations, hydroxyapatite synthesis, and product characterization.
First, material preparation. This was done by making the Kupang shell powder. First we collected the Kupang shells, then we washed and dried under the sun for 24 hours. Next, pounded the Kupang shell using lumpang and pestle, then filtered using 200 mesh filter. After we made the Kupang shell powder, we take 100 grams of Kupang shell powder for each sample. There are 3 samples. Each of the sample calcined at a different level for 24 hours. Sample 1 at 800 Celsius, sample 2 at 900 Celsius, and sample 3 at 1000 Celsius. Each of the sample then mixed with the ammonium phosphate solution and stirred for 30 minutes until it became slurry. Then heated on 160 Celsius for 24 hours.
Hydroxyapatite synthesis stage is carried out by applying each sample of Kupang powder that has been calcinated as much as 50 grams. Insert the shell powder into the bigger glass and place on the top of the magnetic stirrer. Prepare 100 ml of the solution of the ammonium phosphate. Drip the solution of the ammonium phosphate on the Kupang powder little by little until the solution becomes slurry. Stir in the mixture for 30 minutes, measuring the pH of the mixture using pH scale. If the pH has not reached 12, it is added to the solution of the ammonium phosphate. Put the mixture in the oven at 160 degrees Celsius for 24 hours. Each sample is then mixed with the solution of the ammonium phosphate, then stirred for 30 minutes. After that, it is heated to a temperature of 160 degrees Celsius for 24 hours.
The result of the research consists of the result of physical characterization and characterization using FTIR test tool. Physical characterization result is done by observing the physical appearance of each samples and products. Based on the table, calcined Kupang powder have lighter color than Kupang shell powder without calcination. So as shown on the table, bone graft from Kupang shell powder without calcination has brownish color. Bone graft from calcined Kupang powder at 800 degrees Celsius have light brown color, while from calcined Kupang shell powder at 900 degrees Celsius and 1000 degrees Celsius has light white color.
FTER characterization result. This step is done by using FTER Fourier transform infrared spectroscopy to identify chemical bonds in samples and products. The result of the identification is a spectrum from each sample and product. If the chemical bonds are similar to the standard HAP, it could be concluded that it is real synthesis HAP. So this is the FTER samples. A is Kupang shell powder without calcination. B. Calcine Kupang shell powder at 800 Celsius. C. Calcine Kupang shell powder at 900 Celsius. And D. Calcine Kupang shell powder at 1000 Celsius. Based on the diagram of FTR sample, calcium Kupang shell samples have similar wave spectrum. This shows that Kupang shell powder without calcination and calcium Kupang shell powder has different chemical bonds. The identification of chemical bonds using FTR is also done with the product to make sure that the products that are produced are actual hydroxyapatite synthesis. HAP or hydroxyapatite consists of functional groups such as hydroxyl, carbonate, and phosphate. So this is the FTER of the product. A. Bone graft from Kupang shell powder without calcination. B. Bone graft from calcined Kupang shell powder at 800 Celsius. C. Bone graft from calcined Kupang shell powder at 900 Celsius. And D. Bone graft from calcined Kupang shell powder at 1000 Celsius. Based on the diagram of the product, the wave spectrum consists of functional groups such as hydroxyl, phosphate, and carbonate. The results are similar to the FTER spectrum of standard HAP. So this is the functional group of each spectrum. It shows the wave number of each spectrum.
Based on the table of the functional group of each spectrum, the presence of a functional group in each product on wave number is similar to the standard hydroxyapatite functional group. This shows that the product that is produced is actually synthesis of hydroxyapatite. In standard of synthesis hydroxyapatite, the hydroxyl functional group is found at a wavelength of 3568 cm, while hydroxyapatite synthesis, the functional group is found at wavelength of 3472.37 cm and 3838.89 cm. According to Harlim, 1986, the hydroxyl functional group formed in hydroxyapatite synthesis is at 3800 cm to 3200 cm. In standard of hydroxyapatite synthesis, the phosphate functional group is found at wavelength of 1041 cm, while in hydroxyapatite synthesis, the functional group is found at wavelength of 1016.68 cm to 1092.61 cm. According to Van Diver, 2004, phosphate group can be found in hydroxyapatite. In stretching vibration with wave number of 1010 cm to 1090 cm.
In standard HAP, the phosphate-phosphate functional group is found at wavelength of 570, while in HAP synthesis, the functional group is found at wavelength 539.98 to 592.82. Phosphate groups in HAP can also be found in bending antisymmetric vibration with wave number about 530 to 603 by Van Diver in 2004. In standard HAP, the carbonate functional group is found at wavelength of 869, while in HAP synthesis, the functional group of carbonate is found at wavelength 737.54 until 874.13. The existence of carbonate functional group is often considered a field due to its uncontrollable existence by Setiawan in 2012. The presence of carbonate functional group due to the reaction between hydroxyapatite (HAP) and carbon dioxide contained in the free air during synthesis and heat treatment. However, this existence of carbonate functional group cannot be said to be bad, because indeed in human bone themselves have, which is a natural substitution.
It can be concluded that Kupang shell can be synthesized into hydroxyapatite as an alternative bone graft materials that is halal and affordable. The result of product characterization using FTIR indicate that there are hydroxyl functional group, phosphate, and carbonate, which are hydroxyapatite functional group. So our future work is to further testing of bone graft is required to determine the level of toxicity before bone graft is applied.
This is the research documentation.
These are the references that we use for our research. Thank you for listening. Hope you enjoy. Wassalamualaikum warahmatullahi wabarakatuh.